Welcome back. We're going to continue our discussion. Again, we're adding alkenes to make a dihalide. Okay, so when you have a reaction that goes from an alkene to a dihalide, remember when we did the NBS, I said NBS is very selective versus a Br2. Okay, the Br2 is reacting with, say, light. Okay, it results in the formation of a dihalide. So let me write the product, which is very, very easy. I guess this is the easiest of all of them. Is you write everything the way it is, and you just write 1 Br per carbon. Okay. Now I'm going to sharply contrast this with the next reaction. But what is essentially happening is, I don't want to go deep into the mechanism because I do want to reserve those for a little later when you're a little bit more comfortable going between reactions. As I said, and again, I don't want to do mechanism for every one. We'll do it a little later. Okay, so whenever an alkene reacts with the Br2, you're adding dihalogen. That's what dihalide means, to the 2 carbon that contains the double bond. But what's essentially happening here is somewhere in the reaction, this is happening. Okay, basically you're forming something called, I might have you do this alone because I have explained it. Okay, what you've done here is add a Br. This is called a bromonium ion. Okay, what did I say? Bromonium ion. Okay, let me rewrite it. Basically, whatever carbon containing the double bond, okay, which in this case is this, you want to draw a triangle, put a Br and a plus, and then continue with the rest of the molecule. Okay, what this does is, this is a bromonium ion, right? So the Br attacks from, say, this side, okay, or the opposite side, it doesn't matter, right? So say the Br minus, well, basically you had 2 Br, right? 1 Br resulted in the formation of a ring with a plus charge, so the other Br must be negative. In chemistry, when you have a positive, you must have a negative. Okay, so the negative attacks here, results in ring opening. Again, you do not have to memorize this, nor it is important, nor it is very critical at this point, but we will come back and discuss this. So this is Br, and then the other Br. Again, in this case, I'm writing them opposite. We're not worried about stereochemistry at this point. That's a separate topic that we have to learn considerable amount of time. Yes, stereochemistry is a topic we will learn down the road. But in a nutshell, the 2 things I want to do is, this is called an intermediate. Okay, if I ask you what's the intermediate when a Br2 reacts with an alkene, you should be able to write this is a bromonium ion. And this is very important. It's usually appears on a lot of professional exams. But to actually write the product, you just get rid of the double bond, throw in 2 Brs. Okay, this is alkene going to a dihalide. Let's do the contrasting one, where instead of light, bromine reacts with water. Well, I'm going to write it and then see if it makes any sense to you. Okay. Whenever you have an alkene that's unsymmetrical, like this one, where this contains 1 hydrogen, this doesn't contain a hydrogen. So the Br will go to the less substituted. Again, less substituted means it contains at least 1 hydrogen. And OH goes to the more substituted, right? The one without any hydrogen. Just like we've been learning before. So this is the less substituted, and this is the more substituted, right? So the OH goes there. But even this reaction goes through the same identical intermediate, which is basically you draw everything and draw a triangle, put a Br in the middle, right, a positive charge. This is the intermediate. So you start with the reaction. The reaction goes through an intermediate step before it goes through the product. Okay, and in this case, because this is plus and the other is OH, the OH minus is likely the ion that's attacking the ring, and it results in the ring opening, and you end up having, well, actually in this case, the OH minus should be attacking this carbon, and the ring opens this way. Because you see the Br went with this carbon. So whichever side the OH minus attacks, the Br will be on the opposite side. But that's for more of a mechanistic view. Okay? But what I'm saying here is, if you're contented with the situation, the Br goes to the carbon with less substitution, and the OH goes with the. So this is basically a Markov-Nikov. All right? And so that's how Br2 reacts in two different occasions. Here's one of them, and here's the other one, right? Br2 itself and Br2 with water. And I'll leave you pondering on these two. So the idea here is both of them goes through a bromonium intermediate. Let me rewrite this one more time so it's very clear. You write everything the way it looks. Just write the Br and a plus. And this is called an intermediate, usually written within brackets. And the intermediate is specifically known as bromonium ion. So there are a few takeaways from this, but I do want you to take how to write the product quickly. The OH goes with the more substituted, Br goes with the less substituted, and I'll see you with another video.